Yes, my friends, my second year friends. Now, little bit break in between. I am again continuing with what? Inverse trigonometric functions. Little 4-5 examples left in that inverse trigonometric functions. Almost everything important I have completed. Last man, few more examples. Okay. That I do today and I will complete. I will try to complete this inverse trigonometric functions. Okay, my friends. See, already we have done examples based on these substitutions. If the expression contains root 1 minus x square, what is x? Sin theta. Root 1 plus x square, what is x? Tan theta. Root x square minus 1, even otherwise, only without root also. Substitution is x equal to sec theta, my friends. These are substitutions. And you know, 1 minus cos theta or 1 minus cos 2 theta, 2 sin square theta. What is your observation? 2 theta becomes theta, half of the angle in LHS. Plus means 2 cos square minus 2 sin square plus 2 cos square. Angle is fixed, half of the angle. If it is theta here, it becomes theta by 2, my friends. Okay. Then only one example left with this substitution. If the expression contains root 1 plus x, if the expression contains root 1 plus x and root 1 minus x, my friends, either both, otherwise 1, root 1 plus x, root 1 minus x. In such cases, my friends, I explained well in advance. Minus 1 minus cos 2 theta is this, 1 plus cos 2 theta is this. Then, my friends, what is this? X. Then what is this, my friends? X pi. It is 1 minus x. What is this? It is 1 plus x. If it is a square root, it becomes what? Square root of these things. Square root of sin square is sin. Square root of cos square is cos. Yes, my friends. If you know these two formulae, if the expression contains root 1 plus x, root 1 minus x, naturally you yourself tells what? The value of x is either cos theta, otherwise cos 2 theta, as we know these two formulas. Yes, my friends. If the note, if the expression contains, if the expression brief contains root 1 plus x, root 1 minus x, then put x equal to either cos theta, otherwise cos 2 theta. Cos theta or cos 2 theta. Yes, friends. Now I do that example which is contains what? Root 1 plus x, root 1 minus x. Yes, my friend. This is the example. This example in your text is there in the miscellaneous exercise. Prove tan inverse root 1 plus x minus root 1 minus x. Down is root 1 plus x plus root 1 minus x. Yes, my friends, equal to pi by 4 minus cos inverse 1 by 2 cos inverse x. Prove tan inverse of this equal to pi by 4 minus 1 by 2 cos inverse x. Tell, my friends, what is this? It is the expression that contains root 1 plus x, root 1 minus x. Naturally, what is your x? Cos 2 theta. Yes, my friends. In this manner, you put what? X equal to cos 2 theta. Then find the value. Root 1 plus x. It is root 1 plus cos 2 theta. What is this? It is root plus means 2 cos square theta, half of the angle. 2 theta becomes theta. 2 theta becomes theta. Yes, friend. What is it? It is square root of 2 into cos theta. Next, root 1 minus x. Root 1 minus x. It is root 1 minus cos 2 theta. It is square root 2 sine square theta. Simplifying root 2 sine theta. Minus is sine plus is cos. Yes, my friends. You have to substitute these two values where? In LHS. In LHS. Yes, friends. Put these values in LHS. In LHS. Right, my friend. LHS. LHS tan inverse. What is the value of root? I directly substitute. It is root 2 cos theta minus root 2 into sine theta. Denominator the same terms with plus sine. Root 2 cos theta minus root 2, no, plus down, root 2 sine theta. Yes, my friends, yes. Then we wanted one more result here, one more result. Just I will remind, we have done many examples based on this formula. This formula, yes. That formula is tan inverse of x plus y or x minus y, anything x plus y or x minus y, denominator is 1 plus xy equal to, tell friend. What is your observation? This must be 1. This must be 1. If it is not 1, bring to 1. Opposite signs, minus plus, otherwise plus minus. This should be the product of these two. X into y is xy. If it is so, I told you to write this as what? Tan inverse of the first minus tan inverse of the second. Tan inverse of the first minus tan inverse of the second. Then we wanted that these must be in terms of tan. Why? Outside is tan inverse. We can make use of this property. Tan inverse of tan theta is theta. Even these, tan inverse 1, pi by 4, tan inverse infinite, 90 degrees. Tan inverse root 3, 60, pi by 3, 1 by root 3, 30 degrees. You know all such things. Superman is this. Tan inverse 1 is pi by 4. Yes, my friend. In this case, you have to divide both numerator denominator by what? Root cos theta. Divide both numerator and denominator of this bracket. It is understood by what? Root 2 into cos theta. Yes, my friend. LHS equal to tan inverse. You are dividing this by this, you get 1 minus this by this. Root 2 cancels with root 2. Root 2 cancels with root 2. Sin theta upon cos theta is tan theta. My friends, written direct, digest. Digest, it is here. I have written this divided by this. Same cancels 1 minus. Only root 2 cancels, my friend. Sin theta upon cos theta is tan theta. Cancels 1 plus root 2 cancels with root 2. Sin theta upon cos theta is tan theta. My friends, once again corner, which is the source of results. See, this must be 1. Second observation is what? Opposite signs. Third observation, This must be product of these two. 1 into tan is tan. Then if it satisfies tan inverse of the first minus tan inverse of the second, right? This equal to tan inverse of the first minus tan inverse of the second. Second is tan theta. Tell my friend, what is this? Pi by 4 written minus written tan inverse of tan is theta. Then you have to just get the value of theta. Where? Here. X is cos 2 theta. Bring cos inverse x is 2 theta. What is theta? 1 by 2 cos inverse x. Equal to. I write, then I will explain. Pi by 4 minus 1 by 2 cos inverse x. Why? Because of this. My friend, x is cos 2 theta. Yes, cos inverse x, bring this side. 2 theta. Bring that to 1 by 2 cos inverse x is theta. Yes, my friends. So, the value of theta is substituted as what? Half cos inverse x. And tan inverse 1 is pi by 4. My friends, this is your example. Which is, you can write, when you started with LHS, you have to end with RHS. This is RHS. Yes, my friends, may be clear. You have to prove this equal to this. I told, if this expression, put x equal to cos 2 theta, then find the value, root 1 plus x, 1 plus cos, 2 cos square, square root, minus 2 sin square, square root. LHS, substitute these values. Divide both numerator, denominator of this bracket, no need to write, by root 2 cos theta. Understood? This divided by this 1 minus root 2 cancels, sin theta upon cos theta, tan. Again, entire thing cancels with this. Root 2 cancels, sin theta upon cos theta is tan theta. Once again, verification of the result. 1 opposite product of these two. Then, so tan inverse of the first plus is plus, minus is minus. Tan inverse of the second. Yes, my friends. Tan inverse 1 is pi by 4. Tan inverse of tan theta is theta. But the value of theta is what? Half cos inverse x. Yes, my friends. This equal to this. Hope understood. Good example. You can get this under 3-mark questions, man. In inverse trigonometric functions, ITF, inverse trigonometric functions, you have 1 mark, 2 mark and 3 mark. 1 mark, 2 mark, 3 mark. There is no provision in what? 5 mark, 4 mark questions. These, my friends. Yes. Next example. Yes. Like this, my friends, once again you need what? One more result, just a reminder. First I will remind that result, then I will start with example. Yes, friend. That example is this. We know that short form cos square theta plus sin square theta identity. Same is what? Instead of theta, my friends, I want to take x by 2. Sin square x by 2. It is also what? 1. Another formula is sin 2 theta or 2a is what? 2 sin a cos a. What is your observation? 2a becomes a half. 2a becomes a becomes a by 2. Therefore, if it is sin x can be written as 2 sin x by 2 into cos x by 2. Yes, my friend. What is another observation is this? If it is a square plus b square plus or minus 2ab, a square plus b square plus or minus 2ab is what? If it is plus, you write plus. If it is minus, you write minus. It is nothing but a plus b the whole square. A plus b the whole square. Just to remind everything what I want to use in the next example, my friends. Next example. Yes. This is your example. It is also another good example. Good example. I think even it is appeared in CET also. Prove. The same example again we will get in calculus differentiation. Prove cot inverse square root 1 plus sin x minus root 1 minus sin x. Denominator same expression with plus in between. Same, it is square root 1 plus sin x plus square root 1 minus sin x. Yes, friends, equal to x by 2, where x belongs, x takes the value between open interval 0 to pi by 4. Open interval 0 to pi by 4. My friends, this is the example. This is the example. Is correct? C. 1. Tell. What is 1? 1 is cos square x by 2 plus sin square x by 2. 1 is cos square x by 2 plus sin square x by 2. Then what is sin x? 2 sin x by 2 into cos x by 2. For 1, substitute. For sin x, substitute. Yes, my friends, I consider that separate. It is square root 1 plus sin x. It is square root 1 is cos square x by 2 plus sin square x by 2. Next, plus sin x, it is 2 sin x by 2 into cos x by 2. Yes, my friends. Down. If it is a square plus b square plus 2ab, it is what? A plus b the whole square. C. A square plus b square plus 2ab is a plus b the whole square. What is a? Cos x by 2 plus sin x by 2 the whole square. Tell my friend. Square root cancels. Square root cancels. Equal to what? This is equal to square root cancels. It gives what? Cos x by 2 plus sin x by 2. Yes, my friends. Therefore, from this you get therefore root 1 plus sin x is, see, it is cos x by 2 plus sin x by 2. Similarly, if it is plus here, you have plus sign. If it is minus here, you have minus sign. Therefore, it is square root 1 minus sin x. What is this? It is cos x by 2 minus sin x by 2. Yes. Then what you have to do? Just you have to substitute these values in LHS. Put these values in LHS. Yes, correct. This is LHS. It is cot inverse cot inverse value of the above cos x by 2 plus sin x by 2. Friend, minus. What is it? This, I use bracket for this. Cos x by 2 minus sin x by 2. 5 is minus 2. Denominator. This friend, cos x by 2 plus sin x by 2. It is plus here, plus. Plus means no need to use what? Bracket. Minus sin x by 2. Yes, my friend. Simplified. This is cot inverse cos x by 2 plus sin x by 2. My friend, minus cos x by 2. Help. Minus with inside minus is plus. Sin x by 2. Down. My friends, I cancel here. Minus cancels with plus. Cos plus cos is 2 cos x by 2. Cos plus cos, 2 cos. Here what cancels, my friend? It cancels with cos. Then you are left with cot inverse. See, sin plus sin is tan x by 2. My friends, yes, you wanted x by 2 means just reverse it. Above is plus, down is minus. Above is plus, down is minus. My friend, this is plus, down is minus. If it is minus, this minus with minus becomes what? Plus. My friend, this is plus, this is minus, this is minus, this is minus. Yes, here cos cancels, not sin. Cos cancels. You get down is 2 sin. Here, my friend, what cancelled here? Sin cancelled. You are left with 2 cos. Left with 2 cos x by 2. Denominator is 2 sin x by 2. Get cancels. Yeah, it is equal to. My friend, cos by sin is cot. Cot x by 2. Yes. Cot inverse of cot x by 2, which is, my friend, RHS. So, please do this change. Above is plus, down is minus. Above is plus, down is minus. If it is plus, sin cancels, you are left with 2 cos. If it is minus here, minus cos, minus of minus, plus sin here, cos cancels, you are left with sin. Again 2 cancels. Cos by sin is cot. Cot inverse of cot is x by 2, which is RHS, my friends. RHS. Hope clear. So in this case, we are making use of the fact result. Write for 1 cos square x by 2 plus sin square x by 2. Write for sin x 2 sin x by 2 into cos x by 2. So it becomes what? A square plus b square plus 2ab in case of plus, minus 2ab in case of minus. If it is plus 2ab, it becomes a plus b the whole square. Cos x by 2 plus sin x by 2 the whole square. Square root. So if it is plus here, plus. It is cos x by 2 plus sin x by 2. Similarly, instead of plus, if it is minus here, it is cos x by 2 minus sin x by 2. Substitute these values in LHS. LHS. Above is plus, down is minus. Minus of minus, it becomes plus. In the numerator, sin cancels. In the denominator, cos cancels. Cos cancels. These remains, my friends. It is sin x by 2. It is sin x by 2. It is sin x by 2. Cos cancels. 2 cos upon 2 sin, cancellation cot. Cot inverse of cot directly RHS. Yes, my friends. Yes, my friends. This is second example. Second example. Okay. I hope it is clear. Next is third example. My friends, in the third example, I use this result. We know that. Sin inverse x plus cos inverse x is pi by 2. You know, we have done 3 identical results. Tan inverse x plus cot inverse x is pi by 2. Sec inverse x plus cosec inverse x is pi by 2. So from this, my friends, you can shift anyone towards that side. So if you shifted what sine, you get it what? Cos inverse x is pi by 2 minus sin inverse x. It is equally true. Pi by 2 minus sin inverse x is cos inverse x. You can substitute for cos inverse, pi by 2 minus sin inverse. Even you can substitute for what? Pi by 2 minus sin inverse, cos inverse. Pi by 2 minus cos inverse, sin inverse. Pi by 2 minus tan inverse, cot inverse. Like that you can substitute, my friends. Okay. So the next example is 9 pi by 8 minus 9 by 4 sin inverse 1 by 3 equal to 9 by 4 sin inverse 2 root 2 upon 3. 2 root 2 upon 3. Yes, my friends, upon 3. Yes. Take LHS. LHS is this minus this. And what is your observation? 9 is common. 8 and 4. 4 is common. You are left inside. 9 is taken, 4 is out. Pi by 2 is left. Minus. Pi by 4 is taken out. It is what? Sin inverse 1 by 3. Sin inverse 1 by 3 by taking what? 9 by 4 common. But what is pi by 2 minus sin inverse? Pi by 2 minus sin inverse is cos inverse of the same. If it is x, you write x. If it is 1 by 3, you write 1 by 3. Yes, friend, it is 9 by 4 into cos inverse 1 by 3. Cos inverse 1 by 3. Finished. 9 by 4 is there in LHS 9 by 4. But you have to convert from this cos inverse to sin inverse. Tell. What is another example, another result? This you know. Cos inverse x is sin inverse root 1 minus x square. Root 1 minus x square. 1 minus x square. Yes, my friend. Otherwise, what is another one? Yes, see. This is your triangle. This is your triangle. Cos means adjacent side, hypotenuse. What is this? This is root 8 pi. 9 minus 1. 9 minus 1 is root 8. You can convert now. This angle, this angle. Opposite upon hypotenuse. This is 9 by 4. Sine inverse. Sine inverse. Root 1 minus x square. 1 minus 1 by 9. Why? X is 1 by 3x square is this. If you don't want this triangle, triangle means direct answer. Now we have to simplify it. Simplify it. Why? Because cos inverse x is sine inverse root 1 minus x square. All these results we have done. We have done. Yes, my friend. It is 9 by 4. Sine inverse 9 minus 1 square root 8 by 9. What is this? It is 9 by 4. Sine inverse square root 8 can be written as 4 into 2. Denominator is 9, which is 9 by 4. Sine inverse. Simplify it. Square root of 4, 2. Square root of 2, 2. Square root of 9 is 3. Look, is it RHS? Tell my friends. It is RHS. It is RHS. It's clear? Yes, friends. Yes, friends. You want to know this? I will explain once again. You write LHS. Observation. 9 is common in the numerator. 4 is common in the denominator. Taking 9 by 4, you are left pi by 2 minus out sine inverse. Pi by 2 minus sine inverse is cos inverse. Cos inverse. Yes. Rest is what? Convert this sine inverse. Cos inverse to sine inverse. Root 1 minus x square. 9 minus 1, 8 by 9. 8 can be written as 4 into 2 upon 9. 2 root 2 upon 3 is your LHS. Yes, my friend. Last but one example is yes, friends. Prove 2 sine inverse 3 by 5 equal to tan inverse 24 upon 7. 24 upon 7. It is also what? 3 mark question. 3 mark question. Yes, friends. 3 mark question. Yes, it is also good example. Good example. See. Let this equal to theta. Let sine inverse 3 by 5 equal to theta. Then take that side. Then 3 by 5 equal to sine theta. Sine theta. Draw the figure. Draw the triangle. Yes, friend. It is A, B, C. This angle is theta. This is opposite side, adjacent side O, adjacent side hypotenuse. Sine theta. Three by 5, my friend, opposite side upon hypotenuse. Then what is opposite side is 3. What is hypotenuse? 5. Pythagorean numbers, my friend, it is 3. It is 3. So opposite side is 3. Adjacent side, this is what? Hypotenuse. 3 5, then Pythagorean numbers means this is 4. This is 4. Tell my friend what you wanted. You wanted tan theta. RHS. Right. Now tan theta. Tan theta. Opposite side upon adjacent side. 3 by 4. From this, find the value of theta. What is theta? Take this side. Tan inverse 3 by 4. Tan inverse 3 by 4. This tan taking this side becomes tan inverse. My friends, once again, let this equal to theta. Bring this side. Sin theta is 3 by 5. Side reference triangle, theta, opposite, hypotenuse, adjacent. Sin theta is 3 by 5 above, opposite, down, hypotenuse. Pythagorean numbers directly 4. Tan, opposite upon adjacent, theta, tan inverse. See my friend, theta is sin inverse 3 by 5, theta is tan inverse 3 by 4. Then this equal to this, both are equal to theta. Therefore, sin inverse 3 by 5 equal to tan inverse 3 by 4. You have 2 here, multiply by 2 sin inverse 3 by 5 equal to 2 tan inverse 3 by 4. Yes, my friend, you want to simplify this 5. You wanted this 2 sin inverse 3 by 5 is wanted. Then this doesn't want, you must change this. You know, my friends, what is formula? 2 tan inverse x is tan inverse 2x upon 1 minus x square. This formula, because of this, yes, 2 tan inverse, use bracket, 2 into x 3 by 4, denominator 1 minus x square, square of this 9 upon 16. Simplify this. It is tan inverse. It is 6 by 4. I did division like this. What is this? Cross. 16 minus 9, 7 upon 16. Simplified. This is tan inverse. Friend, 6 by 4. Reciprocal. 16 upon 7. Yes. 4 cancels with 16. 4. What is this? Equal to tan inverse 6 into 4, 24 upon denominator is 7. Tell my friends, is it your RHS? Otherwise, same. 2 sin inverse 3 by 4 is 2 sin inverse 3 by 5 is tan inverse 24 upon 7. This. My friends, once again I will explain. See. In this case, take this equal to theta. Yes. Find the value of sin theta, 3 by 5. Reference triangle, opposite hypotenuse. If it is theta, opposite hypotenuse, remaining Pythagorean numbers. You wanted this side tan inverse, right hand, tan theta. This upon this. Find theta, bring this side tan inverse. Theta, tan inverse of this, theta sin inverse of this. As theta is same, you have sin inverse equal to tan inverse. You wanted 2. Multiply both sides by 2. 2 tan inverse x. Use this formula. 2x upon 1 minus x square. Simplify. 6 by 4. 16 minus 9. 7 by 16. Reciprocal. Cancellation. 24 upon 7, which is your answer, my friends. Okay, this is 1. I do 1 the last. That finishes your inverse trigonometric functions. inverse trigonometric functions. Oh, clear, clear. Yes, friend. Show that. Last example of this. Show that sine inverse 3 by 5 minus sine inverse 8 by 17 equal to cos inverse 84 upon 85. 84 upon 85. Yes, friends, a slight same type, little lengthy, but 3 mark only. It is also 3 mark. 3 mark. See, friends, how to do this. Yes. Yes. Take, friend. You take this equal to A, this equal to B. Right. Let sine inverse 3 by 5 equal to A and sine inverse 8 by 17 equal to B. Yes, friend. This gives sine A is 3 by 5. 3 by 5. This you get taking sine this side. Sine B 8 by 17. 8 by 17. Then you wanted cos A. Cos A. Right, my friend. Cos A. Cos A is what? Adjacent side. Actually, you must use what? Your brain power. Brain power. Triangle, my friend. This is A. Sine means opposite. Hypotenuse. Remaining Pythagorean number. Then you have to write cos A. Adjacent upon hypotenuse. Direct, my friend. This is better. Better. Direct. You are in PUC second year now. You can write. And the same thing here. Same thing here. Another triangle. Friend, this is B. Sine opposite side 8. This is 17. Once again, Pythagorean number. You must remember those things, man. They help a lot in CET. 8, 17. These are the Pythagorean numbers. 15. Write cos B. Cos B. Cos B. Adjacent side upon hypotenuse. Yes, understood. RHS is cos inverse. Take cos A minus B. Now, substituting these values. Right. Cos A minus B. Now, cos A minus B theorem. Cos A cos B plus sin A sin B. Sin A sin B. Yes, equal to cos A 4 by 5. Cos B 15 upon 17 here. Cos B plus sin A 3 by 5. Sin B 8 upon 17. What is this, my friend? 60 upon 17 into 5 plus, what is this? 24 upon 85. Friend, LCM 85. You would add this 60 plus 24. 60 plus 24 is 84 upon 85. Yes, my friends. Therefore, cos A minus B. Cos A minus B is 84 upon 85. Take off that side. A minus b cos inverse 84 upon 85. What is A? Sin inverse 3 by 5. What is B? This. Therefore, it is A sin inverse 3 by 5 minus B sin inverse 8 by 17. 8 by 17 equal to RHS is cos inverse 84 upon 85. Yes, friend. This minus this equal to this. So, in such examples, method is same, simple. This is A, this is B. Sin A, cos A you have to find. Sin A, cos A you have to find. If RHS is cos inverse, start with cos here. If the RHS is sin inverse, you start with sin here. Here, if it is minus, you write minus. If it is plus here, you write plus here. Yes, it is minus. RHS is cos. Cos A minus B here. Values are available, all values. Substitute. Simplify. 60 upon 85 plus 24 upon 85. 85 is LCM. Addition 84. So, take this side. Cos becomes cos inverse. Substitute the values of what? A and B. This gives you an example, my friends. My friends. It is a good example. And one example you can do at home yourself. Yes, friends. I write here. These two examples you have to do it yourselves. DIY 1. Proof. This is cos inverse 12 by 13 plus sin inverse 3 by 5 equal to sin inverse 56 upon 65. This is 1. Second proof. Yes, cos inverse 4 by 5 plus cos inverse 12 by 13 equal to cos inverse 33 upon 65. Same types, my friends, same types. Yes, these two you do at home. One sample I have done. My friends, this finishes what? Inverse trigonometric functions, complete chapter. Remember, on this you have 1 mark, 2 mark, 3 mark questions. 3 mark questions. Because of the corona, I do not know the change in the question paper. All the pattern was what? Without COVID-19. Now you are facing still what? Corona. Therefore, we do not know the pattern of question paper. If it is like earlier, you have 1 mark, 2 mark and 3 mark questions. 3 mark questions. Even in CET, 2 examples under CET on inverse trigonometric functions. Is correct? 2 examples. Yes, my friends. Now, this finishes inverse trigonometric functions. Next is calculus. It starts with continuity, differentiation, integration. That some part of the continuity already you have done in first year. Continuation is there. Okay, I will see whether to start directly with differentiation, whether I will first take what? Continuity, then differentiation. I will think of it and I will go with next class. Yes, my friends. Thank you very much.